Hey guys, welcome to Deep Dive Coding. Today we solved LeetCode problem of the day, and this is a very easy problem tagged by LeetCode. In this video I will explain two approaches, and one is using the built-in functions and another one is these algorithms, brain Kernighan algorithms. So in this video I will go through this way. First explain the questions, then go to the approach, then code explanations, then give the algorithm parts and complexity analysis. Now let's start the video. So question is simple. We are given a left and a right as an integer, and these two things are lesser than or equal to 10 to the power 4 limit, and we have to give the output. What we give to output, like including left to right, what are the numbers have their set bits count is prime. That means if you consider 6, its binary representations is 110, so number of set bits is 2. You can say number of set bits 2. For 7 it is number of set bits is 3. For 8 number of set bit 1. For 9 it's 2, and for 10 it's again 2. So how many of our primes, like number of set bits is prime, so 2 is prime, 3 prime, 2 and 2, so there are 4 number, that's why output is 4. So we have to do the two things. First we have to calculate the number of set bits, and second thing is to check whether it is prime or not. These two things have to do. Now coming to the approach part, first of all we just iterate through a num. We are taking a num and we iterate through left to right including both, and we have to count the number of set bits of each numbers. This can be done in the two way. First one is we can use the built-in pop count, or that is built-in functions in any language, C++, Java or Python. There are corresponding languages. I will discuss over here C++, but Java and Python versions is exactly similar in structures, and you can find it in descriptions. Okay, so now we have the range of integers that will go up to 32 bits, can be represented under the 32 bits. So basically number of set bits can go up to 20. Why it's 20? If you look into the constraint part, 10 to the power 4, it can be represented under the 20 bits only. So if you able to find the primes which is 1 to 20, and you get the answers, so we can pre-compute this range. And if we have an array of 20 size, and we just take an boolean array, and all those places, that means 2 3, all the prime numbers places are represented as 2, otherwise it's false, then we can simply go to that index according to the number and return the whether it is true or false. So we can, instead of using that array, we can use the a particular number. You can say particular number that have the 32 bits in its representations. So we have 32 places, so we can just update our that numbers particular bits to the set if it is prime. That means let's take this number. So index starting from over here 0 1 2, 2 is prime number, that's why it is set. Now 3 4 5 again set, 6 7 8 9 10 11 is set, 12 13 also set, 14 15 16 17 set, 18 and 90, and finally it is 20. So all the places, that means 2 3 5 7 11 13 and 17 and finally 19, these are the prime numbers in the range of 1 to 20. So in those places bit is set, that means it is 1. Able to count this number of set bits, we just need to check whether that position is set or unset. According to that we just increase our count. If it is set, that means it is invalid, we just increase our count. So coming to the coding part, but before going to the coding part, please like and subscribe the channel and comment that it is helpful or not, or whatever you want to comment. Now come into the coding part. We are given two arguments, left and right. We just initialize count prime set bits equal to 0. That means we just track those count, and we have to use the mask, and these are the prime numbers as I already discussed, and it's binary. And if you convert this binary to integers, that means in decimal format, it is the exactly these numbers. Now we iterate from left to till right, and we just need to check, like we are using built-in pop count. So it is in the C++, but Java and Python same versions is you can find it in the descriptions. Now what we have to do, we just first we get the built-in pop count. That means how many number of set bits is already there. When we get this number of set bits and we want to know at that index in the magic mask is set or unset, to do that we just use the magic mask and right shift till the bit count and ampersand with 1. It will give you whether it is, if it is set, that ampersand with 1 will give you 1, and then we increase our answers. Otherwise we just keep this part. At last we just return our answers. This is an optimal approach. You can consider the time complexity is big of right minus left, right minus left times we are using built-in pop count. That can be done in big of, you can d number of digits it considers. And for the space complexity, we are not taking any extra space, so you can consider big of 1 space complexity. But we can over here one thing we can optimize, that over here we are using built-in pop count, although this is a CPU optimized instructions, but you can find it a manual way. That's an algorithm. This is a popular algorithm, that is, you can spell it correctly. If that will simply efficiently count the set bits in a number. This is the heart of the algorithm. N equal to n and n minus 1. That means number of bits, it will run till the number of set bits. So let's try to dry run an example. Let's n equal to 10. So if you plot in binary format, this is a binary format 1010. Now take the n minus 1, that is 9. So it will be like over here 1 and 1 over here and 0 0, and try to take AND operations of these two numbers. So it will give you 1 0 0 0. This will give you now n equal to 8. This is binary 1 0 0 in the second iteration. This is first iterations, and this is iteration 1, and this is iteration 2. Okay, now n minus 1 is 7. This will be this one. Now take again ampersands, it will give you all zeros. So n equal to 7, it is have the 0 1 1 and 1, and it will give you the n equal to 0, and at the n equal to 0 you just stop. So as many the set you can, over here you are two set bits, this one and this one, so that's why it is go till the two that much number of iterations. But if you have the more number of set bits, it will go to that much number of iterations. So you can consider, if you try to do this in the, if you instead of using built-in pop count, you can use these functions also. Count set bits, it will take n as integer, that is, you can consider number, and we just initialize and count, and till the n greater than 0 we just update n and n minus 1, and count is increased. At the last we just return our count. So it will run till the number of set bits, number of set bits in number, in a given number, you can consider n. And in here you can consider number of set bits can go up to 20. So you can consider this is the functions complexity at max. You can consider this is also big of 1. Thank you guys, thank you for watching. Stay tuned for more videos.